Hi students. In this lecture, we are going to learn superposition of waves. Let us see what is it. Let us consider two waves traveling in same direction. Two waves traveling in same direction. Let us take first one equation is y1 equal to it is a1 sine omega t minus kx. So omega t minus kx. Its meaning is it is traveling along positive x-axis, right? And take next one y2 equal to it is a2 sine omega t minus kx plus 5. Okay, so we are taking two waves traveling in the same direction having same frequency. We can see here we have taken omega same omega and omega. That means both having same frequency. And omega t minus kx, and this also omega t minus kx. So both are propagating along positive x direction. And phi is now phase difference between those two waves. So two waves traveling in same direction, having same frequency. Then when they superimpose, so what is the resultant wave? Means what is its amplitude? How to calculate that? Okay. See how to calculate. Resultant of these two is given by y equal to y1 plus y2. This is according to principle of superposition. This is what we have discussed in simple harmonic motion. There we have discussed lines of oscillations are same. Lines of oscillations are mutually perpendicular. Right? These two cases we have discussed. Now exactly same principle here also. Right? Now resultant of those two waves. Then after making calculation, so this comes out to be it is a sine omega t minus kx plus alpha. So we have taken expansion of this y2 sine omega t minus kx plus y expansion of this. After that, rearranging and simplifying, then we are going to get a sine omega t minus kx plus alpha. Now in this, a is given by square root of a1 square plus a2 square plus 2 a1 a2 cos phi. So this is result what we have learned in simple harmonic motion. So same calculation. If you're having any doubt how we got this one, we can refer once simple harmonic motion in that superposition of two SHMs. Okay, right. And coming to the value of alpha, alpha is given by tan alpha is equal to it is a2 sin phi by a1 plus a2 cos phi, right? See, from this equation, what we can say is when two waves traveling in same direction having same frequency on superposing, again we are going to get a wave of same frequency. Again we are going to get a wave of same frequency traveling in the same direction. That is what we can say from this equation. And now we have to get what is the value of A and what is alpha. And A is given by square root of A1 square plus A2 square plus 2 A1 A2 cos phi. And tan phi equal to A2 sin phi by A1 plus A2 cos phi. So by seeing these two, what we can say is we can take amplitudes A1, A2 as two vectors and phi, that means phase difference between them as angle between those two vectors. So I'm drawing diagram here. A1 is one vector, means taking the amplitude as one vector, and A2 as one more vector. Now between these two angles now, that is a phase difference. Then this is now resultant. An angle made by that with A1 is alpha, right? So this is what we have discussed even in simple harmonic motion. Okay, right. Let us see now. Yeah, and take here some one important point is principle of superposition is valid only for small displacements. It is only for small displacements. Why only for small displacements means when displacement is a small, restoring force is a proportional to displacement. That means F equal to Kx. That means Hooke's law is valid. So whenever Hooke's law is valid, we can take superposition of two waves or superposition of two SHMs. Okay. So this is now what we have taken, right? Equation A1 sin omega t minus kx, A2 sin omega t minus kx plus phi, right? And resultant of those two, y1 plus y2. This is according to principle of superposition. Then finally we get y equal to a sin omega t minus kx plus alpha. So from this we are saying that the resultant is also a wave traveling in the same direction with the same frequency, omega same, and the value of a square equal to a1 square plus a2 square plus 2 a1 a2 cos phi and tan alpha. But alpha is given by a2 sin phi by a1 plus a2 cos phi. Right? This is about case 1 where waves are traveling in same direction. Right? Now see next one. So when two waves are superposed, then corresponding amplitude may be large or may be small. You can see in the previous one, right? You can see in this one, a square equal to a1 square plus a2 square plus 2 a1 a2 cos phi. If phi value 0, this becomes a1 plus a2 whole square. That means a value is a1 plus a2. So phi value 0, 2 pi, 4 pi, 6 pi and so on. For all these values, A becomes A1 plus A2. That is what we call constructive interference. That is what we call constructive interference. I am writing here. So we got condition. So we got A equal to square root of A1 square plus A2 square plus 2 A1 A2 cos phi, right? This is what we got. Now in this, if phi equal to if phi equal to 0, 2 pi, 4 pi and so on. That means we can generalize that if a phi equal to 2n pi, then a becomes a1 plus a2. A becomes a1 plus a2 means amplitude becomes maximum. I am repeating, whenever phase difference equal to 0, 2 pi, 4 pi and so on. So when you generalize, if phase difference becomes 2n pi, then amplitude of the resultant wave will be maximum. Right? This is what we call constructive interference. This is what we call constructive interference. So condition for constructive interference, that is, so condition for constructive interference, that is phi is phase difference equal to 2n pi, or same thing we can write path difference. So path difference equal to, it is 2 pi by lambda, 2 pi by lambda into, just a minute. Before writing this, I will explain one point here. That is, right. Earlier we have discussed one point, that is, consider a wave propagating along positive x. If one point makes one oscillation, energy propagates along x-axis by a distance lambda. It travels a distance lambda. That means now this point is about to oscillate. Okay. That means for this point, phase is 2 pi, and for this point, phase is now 0. So lambda distance corresponds to 2 pi phase. If distance is x, what is now corresponding phase? Right? Then what we are saying is corresponding phase difference equal to, it is 2 pi by lambda into path difference, that is now here x. Okay, that is now x, 2 pi by lambda into x, that is a phase difference, or writing this as k into x. Okay, right. Now using that result here, condition for constructive interference, phase difference equal to 2n pi, and 2 pi corresponds to lambda. See here, 2 pi corresponds to lambda. So replace 2 pi with lambda. Then we can write condition for constructive interference. So path difference. What is it? Path difference should be equal to, in the place of 2 pi, write lambda. It is now n lambda. So in terms of phase, 2n pi. In terms of path, it is n lambda. So this is a condition for constructive interference. Okay. See, what is the meaning of this? Let us consider a wave is propagating like this. And here one more wave traveling in the same direction. It is now like this. We can see diagram. Crust is over crust. Trough is over trough. So when crust falls on crust, that means this amplitude positive, this also positive. So when crust is falling over crust, or trough is falling on trough, then that is called a constructive interference. It is crust is falling over crust. I will make diagram here. Crust falling over crust. Then sum of these two, that means we get maximum amplitude. In the same way, coming to trough falling over trough. Trough is falling on trough, then amplitude is maximum. So meaning of path difference n lambda or phase difference 2n pi. That is, crust is falling on crust, trough is falling on trough. This is example for constructive interference. Right. Now coming to destructive. So destructive means wave traveling like this and one more wave. But this is now trough and crust. So here crust is falling over trough. That means this displacement is a positive and this displacement is negative, right? So when crust is falling over trough, the amplitude is minimum. That is A1 minus A2. And here trough is falling over crust. Trough is falling over crust. So this is what we call destructive interference. Okay. So constructive means crust is falling over crust, trough is falling over trough. That is what we have seen here. Then amplitude is maximum. Coming to here, crust is falling over trough, trough is falling over crust. So this is what we call destructive interference. And condition for this one is phase difference equal to, so phase difference equal to, let us take here. So phase difference equal to, it is 2n minus 1 into pi. Suppose n equal to 1, it is a pi. N equal to 2, 3 pi. So pi, 3 pi, 5 pi and so on. So whenever phase difference equal to 2n minus 1 into pi, then it is a destructive interference. Or in terms of path difference, in terms of path difference, it is written as, so replace pi with lambda by 2. So it is a 2n minus 1 into lambda by 2. Because we have discussed here, lambda corresponds to 2 pi, right? So pi corresponds to lambda by 2. So that is what we have taken here. It is 2n minus 1 into lambda by 2. So condition for destructive interference, phase difference equal to 2n minus 1 into pi or path difference equal to 2n minus 1 into, in the place of pi, lambda by 2. Right? In that case, amplitude will be A equal to A1 minus A2. Means if you take A1 is greater than A2, it is A1 minus A2. When it is a constructive interference, amplitude will be A1 plus A2. Right? So you can take notes here. So you can take points from here. Condition for constructive interference. Condition for constructive interference. Path difference. N lambda where n equal to 0, 1, 2, 3 and so on. Phase difference. In the place of lambda, we have taken 2 pi. See carefully. In the place of lambda, we have taken 2 pi. So it is 2n pi. Okay. Next, condition for destructive interference. So it is phase difference equal to 2n minus 1 into pi, like pi, 3 pi, 5 pi, 7 pi, and so on. So in terms of a path, 2 pi corresponds to lambda, so pi corresponds to lambda by 2. Okay. So this is regarding constructive interference and destructive interference. right? Let us take now one example for this. It is a reflection of a wave from a fixed end. It is a reflection from a of a wave from a fixed end. I will explain here. Right. You can see reflection of a wave from a fixed end. Let us take this is a string whose one end is a fixed. This is a fixed end. Now a pulse is produced on the string which is now traveling towards a fixed end. Okay. So now this is reflecting and moves back. After reflection, it will move back. So now we want to find out what is the pattern of the string after reflection. If you observe carefully, since one end is fixed, that point cannot vibrate. So for that point, displacement must be zero always. Displacement must be zero always. I am marking here with a red. So that point is fixed. So that point cannot vibrate. So displacement of that point should be zero always. So now we are thinking like this. We are thinking like, you just imagine this is one pulse which is moving towards the right side. Imagine a pulse which is having same amplitude but it is inverted. It is inverted, traveling in opposite direction. So now what happens is when the peak comes to this point, I'll show here. Imagine this is coming to this point. It is like this, and this is coming to the same point. It is reversed like this. So since both have same amplitudes, one is a positive, other one is negative. So net value becomes zero, right? And after superposition, this one continues right side, means without any change. And this left one, this is a continuous left side without any change in shape. That means finally what happens is, just a minute. Before reflection, shape of the string, the pulse, it was moving right side. After reflection, it will be inverted. After reflection, it will be inverted. Okay. So this can be taken as a combination of a pulse moving towards right side, a pulse moving towards left side. Combination of these two will give us shape of the string at any instant. Means when it is reflecting, we can get shape of the string by combining this upper one and this lower one. And after reflection, shape is now inverted. That means there is a phase change of pi. There is a phase change of pi. The meaning of shape gets inverted. Okay. So whenever a pulse reflects from a fixed end, its shape gets inverted. So this is what we have to keep in mind. See here. Right. You can see if a pulse reflects from a fixed end, then shape of the string at any time is given by adding an inverted image pulse to the instant pulse. And after reflection, the shape of the pulse gets inverted. So these are the key points regarding reflection of a wave from a fixed end, right? Let us see now reflection from free end, right? And coming to here, see explanation part. So it is now, we are taking here a string which is connected to a ring. This is a ring. One end of the string connected to ring. This ring is passing through one smooth rod. This is a smooth rod. So between the rod and ring, there is no friction. Therefore, ring is free to vibrate up and down. I am repeating. One end of the string is connected to a ring. And this ring is passing through a frictionless, you can say smooth rod. So between the rod and the ring, there is no friction. Therefore, the ring can vibrate freely up and down. Now, a pulse is produced at the other end, which is traveling towards right side. Suppose amplitude is A. So when this is reaching the right end, now ring is free to vibrate, or you can say free to oscillate up and down. Okay. That means now this can be taken as, how to take this one means, this can be taken as a superposition of two pulses, superposition of two pulses, just a bit. It is taken as superposition of two pulses. Let us take like this. One pulse is traveling towards left side and one more pulse, its image, erect image, erect image in the sense having same amplitude. This is A, this also A. Okay. When these two peaks are coming to this point, okay. So crust is falling over crust, right? It is in that way. Therefore, a ring is moving up to a maximum height that is 2A. Okay. And after superposition, the one which is moving right side continues to move right side. The one which is moving left side continues to move left side. That means after reflection, what happens is the pulse will propagate left side like this. That means there is no change in the shape of the pulse. In earlier case, we have seen when it is a fixed at one end, shape gets inverted. But now coming to here, there is no inversion, right? An important point is that ring is moving to a maximum distance. It is a 2A, A plus A. Okay. So this is regarding reflection of a pulse from free end. And see notes for this. So if a pulse is reflected from a free end, then shape of the string at any time is given by adding an erect image pulse to the instant pulse. After reflection, the shape of the pulse does not change, but the free end rises to twice the amplitude of the instant pulse. Okay, this is regarding reflection of a wave from a free end, right?